electrons and solid. All right, it's just the introductions. Actually, this class has been taught in the Stanford University as a graduate course. But after I came to Seoul National University, I offered this class in the undergraduate course. But since this is the last lecture that I can offer, I'm going to retire after this semester. So I decided to offer this class for the graduate students. Actually, if you are from Material Science and Engineering department, maybe you have had these lectures in your undergraduate period, right? So, but the title of the course is different, so you can you can have this class as a credit without any problem, even though you have this class in your undergraduate courses. Anyway, the Richard Bube is a professor, was a professor in Stanford University, and actually I was taught by him. I had a lecture offered by this Professor Bube. He's very nice, nice man. And as it says in the title, we are going to survey the electronic, optical, and magnetic properties of solids. And it's just an introduction course, but it's very important in the material science and engineering. Okay. And as you can see, it starts with the particles and waves. Let me write down. It starts with chapter 1, particles and waves. And the next chapter is just to go for the general properties of the waves. General properties. So this means that even though we start out with the particles and waves, the duality of any substance, elements, whatever, this book actually says we have to look at the materials in terms of the waves instead of the particles. That's why just the next chapter is going to be about the wave, right? So in this book, we want to look at everything in terms of the wave instead of the particles. That may give you a little bit difficulties in understanding of the conceptually, it is not easy to take everything as a wave. But it turns out that if you regard the substance as a wave, then most of the physical phenomena which cannot be understood in terms of the particles can be understood. So we just want to regard everything in terms of the wave, in the wave picture, to understand the physical properties of the phenomena that happens in material science. Okay, and then after this general properties, study about the general properties of the wave, we have to look into the lattice wave, and light wave and the matter wave. Okay? So we have to look everything in terms of the wave. The lattice wave is related to the phonons, and light wave is related to the photons. Okay, the matter wave is just about the electron and holes. Okay, this is a particle picture, and then this is a wave picture. We want to look into the phonons in terms of the wave, and that is going to be called lattice wave. Okay, so we want to look everything in terms of the wave. Then, after survey of these three important properties, then we can go into the quantum physics, the basic quantum physics, which is going to be, we start out with the free electron model. And the reason why we have to look into the free electron model is that we want to understand the band, energy bands. What is the energy bands? We have to realize that any material can have some forbidden energies. The material cannot have that energies, which is really impossible to understand if you look into the electrons and holes in terms of the particles. You cannot understand why the electrons and holes, any matters cannot have a certain range of energies. That cannot be understood if you look into the materials in terms of the particles. But if you look into the materials in terms of the wave, then we begin to understand why the material cannot have the certain range of energies. And the first step to understand that is that we have to make the model on the basis of the waves, okay? And that is a free electron model. And the first task that we're going to do is to understand the energy bands in the materials. Actually, the energy band means we want to go into the forbidden energies. We want to understand this, and this is the basic for the quantum physics, okay? And then we are going to apply this basic understanding for the light optical properties, okay? Optical properties. Well, as a matter of fact, this optical properties is a very complicated physical phenomenon. You have to dedicate a whole year or maybe 3 or 4 years to understand just the basic of optical properties in solids. But here, the reason why we have the optical properties chapter right after the energy band is that we just go through the just the basic introductions. We are not going to go anything deeper than the surface in these chapters. We just get a taste of it, okay? And then, really important, the main chapter of this lecture is the electrical properties, okay? We want to understand especially semiconducting properties. semiconducting properties of materials, of solids. Here, the semiconducting property, it does not mean that the electric conductivity is in between metal and insulator. Metal we just call the conductor, right? And people usually misunderstand about this semiconducting properties as is in between, the conductivity is in between metal and insulator. That is a semiconductor. That is a definition of a semiconducting nature. But that's not true. The semiconducting means it's not in between, it's half of these two. No, not that, but the conductivity can be controlled by our will. That is the definition of semiconducting properties. Okay? It's usually the semiconductors like silicon and the 3,5 gallium arsenide, indium phosphide, whatever. These semiconductors are usually insulated by its nature. It's just insulator. But different from the normal insulator, these semiconductors can be a metal, can be a metallic conducting by just doing something, on purpose, like doping and the shining light and the heating. All those things can make this insulator to the conducting material. That is the semiconductor. Okay, so the main topic of this electrical properties of solids, we want to deal with semiconductors. We are not interested in the metal or insulator. Okay, in the metal and insulator, whatever you do, it just stay as a metal. It just stay as an insulator. So naturally, we are interested in the electrical properties. Okay. In semiconductors. And the last chapter is going to be the junctions. Chapter 10 is going to be the junction. That is actually, that is the, what do you call it? That is the contact of two opposite electrons and holes. When you have a same material or different material, whatever, and then you call, if that is, that material's conductivity of that material is controlled by the electrons, we call that N-type. If the conductivity is controlled by the holes, then we call it P-type. Okay, if you put N-type next to P-type, somehow, then we are going to have amazing phenomenon. Just to putting those two things together creates amazing things. That is the junctions. Okay, so we are going to look into the junctions, and mainly we are going to go for the transistor characteristic. We want to understand the transistors, how it works, why the transistor can replace the vacuum tube, the things like that. Okay. The reason why I call this the last chapter is that even though this book has a chapter 11, the magnetic properties, I have lectured this class for last 30 years, but I never get into the junctions. We just run out of time. I just go for after the electrical properties. I have to go to the magnetic properties because 3 or 4 lectures left at this moment, every time. in the last 30 years. But the reason why I just omit the junction is that I have a graduate course class for the junctions, especially operation principles of silicon transistors, things like that, okay, in the graduate course. So I have told my students that about this chapter is going to be covered by the graduate course, another course that I'm going to offer in the graduate course. So in this class, we want to omit this, and then we have to go to the magnetic properties, because the name, the title of this course is EOM, actually, electrical, optical, magnetic properties. So I just skip this junction chapter and then go for the magnetic properties. But this time, this is my last lecture in Seoul National University. I don't have a class for the junctions. So I think the magnetic properties you can just review on the book. I'm not going to tell anything more than what has been written on the book in the magnetic properties chapters. Because as its name says, the magic. Still now, we do not understand of the magnetic properties totally. For example, in the magnetic properties, N and S cannot be separated. Nobody knows why. You have a big magnet, you cut it, then here you're going to create NS. You cannot never isolate N and from S, whatever, okay? Electrons and holes, it cannot be isolated, right? The positive and negative, we can have a isolated independent poles about the electrical properties. But in the magnetic properties, the N and S cannot be separated, and nobody knows why. That's just one example. We still do not know much about the magnetic properties. So in this lecture, naturally, we just covered what it says in the book. So I decided in this class, we may not have this class chapter. We're going to go for the junction chapters in this class. Okay? That is the general idea of this class. And then I don't think you can actually write down anything. But from time to time, I'm going to prepare some handouts if you need something. And probably in this lecture, I may give you some homeworks that are going to help you understand the lectures, okay? And this class has been uploaded in the YouTube. So if you think busy, or you don't have to really come here if you are busy and researching, of course. Okay? You don't have to come. It's going to be uploaded. Every lecture is going to be uploaded in the YouTube. We are not going to have a class next week, Monday and Wednesday. We are not going to have a class because I have to attend the seminar. Any questions? If you want, we can have a midterms. But if you do not want, then I'd rather go for the chapters instead of just using my time for the midterms. Okay. How many of you are coming from outside the material science and engineering school? Where are you from? Business? Or physics? Physics. That's interesting. Physics department. And you're the only one. Okay. I'll see you on Monday a week. Next week we don't have a class, okay? If you have